Welcome to Chem Plus. Welcome to Chem Plus. We have decided to look at cooling curves. You usually meet this in Key Stage 4 chemistry. We have already discussed, or you must have already learned about the three states of matter. What do those particles represent? Particles in a gas, well done. What do those particles show? Particles in a solid, well done. What do these particles show? Now it's only one left, isn't it? Particles in a liquid, well done. But apart from that, you are required to be able to explain why are the particles in a solid close together, and why are the particles in a gas far apart, and which ones have got the highest energy. Is it the solid particles or the gas particles? Okay, let's just give an example. In a solid, the particles are very close together because they've got strong forces of attraction holding them together. They do vibrate in a fixed position. It's not like in a gas the particles are not moving. They vibrate in a fixed position. And in a liquid, what do? Well done. They are still close together, but they can swap positions. But the particles with the highest energy are the gas particles. Because we are drawing a cooling curve, we are starting from a gas. The gas will cool down through that stage, and it cools into what? Into a liquid, and the liquid, as we cool further, becomes a solid. You are required to spell out what's happening here. The temperature drops, remains constant, remains constant. What's happening there between the gas and the liquid? That's a change of state. That's condensation. And what's happening between liquid and solid? That's another change of state. That's freezing. Well done. Right, we have all done three states of matter, haven't we?
Yes, sir.
Okay, what are the three states of matter?
Gas.
Solid, liquid, and gas.
Solid, liquid, and gas. That's correct. So today we're going to look at the cooling curve of acetyl alcohol. We have prepared acetyl alcohol for you, 16 sets of acetyl alcohol. It's already frozen. So what are we going to do in this experiment? We are going to put hot water in a beaker. Okay, all you need is you take an empty beaker to your table, then I will come with the hot water. This is just to make sure that in terms of safety we are all covered. Is that okay?
Yes, sir.
So what you basically do is you put your hot water to 150. Is that okay?
Yes, sir.
Then you put your acetyl alcohol in there.
Yes, sir.
Yes, sir.
Right? In the beginning of the experiment, there's nothing that you're doing. You're just trying to make sure that the acetyl alcohol melts. Is that okay?
Yes, sir.
When it's molten, when it's liquid, you then take a test tube rack and put it on a test tube rack. Then you record the first temperature on the test tube rack. Is that okay?
Yes, sir.
Then after 1 minute, you record the temperature again. After 2 minutes, you record the temperature again. Is there anyone who's not very clear with this experiment? Yes, ask a question.
So, with the hot water in the beaker, what would happen if we spill it on the table?
You get tissue and just dry it off. Now, as explained in the video, you will have a table of results like this where you are going to record. It's a liquid now. When you start, what is the temperature and what is the physical state? You could say 70 degrees liquid, 69 degrees liquid, 64 degrees. You actually have to practically do measuring the temperature as the liquid is cooling down. You measure the liquid cooling down. I put the arrow there because you might need more time going down. Well done. Now, you plot a graph and you should be able to explain what that graph means. you should be able to explain what that graph means in terms of the particle model. Because this is a virtual lesson, I have given you a table of results. If you want to pause and draw your own graph, you can. Right. I tried to draw a graph, and this is what I came up with. And you can see my graph there. I have got the temperature dropping, and here the temperature looks constant. That's where there's a change of state, and here you can see the temperature dropping again. When you do this, you should label your y-axis and you should label your x-axis as well. So when you analyze the results of the results before this slide, you will see that there's a section where there's 68, 68, 68. The temperature will remain constant when there's a change of state. I hope you have learned quite a bit, but this is the time you should now go and dig deeper. Go and dig deeper to understand these cooling curves. Go and dig deeper to understand cooling curves. Here.